option is the best, the text option. Okay. All right, I'll write in red today. Okay, so Unit 5 is all about systems of equations. So a system of equations means more than one equation. And so a system could be two equations or two lines intersecting, or it could be even more than two. But this lesson is all about systems of equations where we're talking about two linear lines on the same plane. Okay, so the solution to the system is the coordinate pair that they have in common. It's where they intersect graphically. Now, I want you to think about two linear lines. How many times can a linear line, straight line, intersect with another?
Once.
One.
Once is the max number, right?
Unless they're like on top of each other.
Oh, okay.
And it will be infinitely many times.
Good. So coordinate pair where the lines intersect. Okay. Could the lines possibly not intersect at all? If you have two lines.
Yes.
How? Describe to
If
me.
they're parallel, that means that they're the same space apart and they never get closer.
Beautiful. So let's look at this example right here. Notice our two lines have the same slope. How many times are those lines going to intersect?
None.
0. So they have 0 points in common, which means we would say there are no solutions to that system. Let me move my toolbar. I don't want you there. I want you up there. Okay, good. So Katie underlined the helpful info here. So there are no solutions to this system. And notice those lines have same slope. Okay. So this is an example of a system where there's no solutions, 0 times they intersect. Here is an example where they intersect 1 time. Okay. What do you notice about the slopes of these lines in this image on the left?
They're negative reciprocals because they're perpendicular.
Ooh, these ones are perpendicular, aren't they? Good. They look like they meet at a right angle, right? Okay. Now, they don't have to be negative reciprocals in order for them to intersect. Anytime your slopes are different, so anytime you have two lines where your slopes are different, they will intersect somewhere, okay? So in order to have one solution, you need two lines with different slopes. And then let's look over here on the right side. If you squint really hard, what you actually see here are two lines. One is graphed right on top of the other. And so really, they have every single coordinate pair in common, meaning all these coordinate pairs are solutions. And because the lines go on forever in both directions, because we know about these arrows, that means we have an infinite number of solutions. Infinite number of solutions. So there's 3 scenarios when we're talking about systems of equations. You can have one solution where the lines have different slopes. You can have no solutions where the lines have the same slope. The lines are parallel, they'll never intersect. And then lastly, you can have one line that's graphed exactly on top of the other. So basically they're the same line and they have an infinite number of solutions. Okay, those are the 3 scenarios. Okay, questions on those scenarios? So let's identify the solutions. I'm going to really challenge you guys to use your math language here. let's identify the solutions graphically. So this unit is all about the different ways that you can identify solutions. This first lesson is how can we find them graphically? So looking at the graph. So let's do that. Hold on, I am magic and I can erase all of those drawings. There we go. Okay, let's identify the solution to each system. So notice singular. So on the left here, where do the lines intersect? And then go ahead and do it on the right. One of you guys can take the left, one of you can do the right. Your solution needs to be written as a coordinate pair if you have a solution. I'm going to fix the graphs while we're at it. Okay, write as a coordinate pair. So this is important with notation that you have parentheses around your coordinate pair. You have an X and a Y. Beautiful. So we're looking for where the lines intersect. We're looking for the only coordinate pair that work in both of those equations. Okay, so Katie, you're doing the left one. What is that coordinate pair? And then Malachi, would you do the right one here? This point is 0, 0. So if that's 0, 0, identify the intersection. That's our solution to that system. Beautiful, written as a coordinate pair. Good, so 2, 4 is the, nice. I love how you're practicing your math language there. All right, Malachi, are you with us? All right. Do you just want to say what the coordinate pair is and I can write it in for you on that second one, Malachi? Nice math language. 2, -4 is the only solution. Good.
Isn't it -2 to 3?
Yes, I think you're right. -2, 3 is that coordinate pair where the lines intersect, which means -2, 3 is on both equations, which means it's the only solution to the system. It's the only place where they intersect. All right, -2, 3 is the solution. Good. All right, questions on those? When you're given the graphs, it's pretty easy. Just pull the coordinate pair off the graph. All right, I'm gonna do a mean trick on you, Katie. I'm gonna move forward. See if I can.
Okay, I finished.
Okay. Just kidding, it's not letting me move. Come on, old Betsy. Anyone else talk nice to their, there we go. Oh, I know why it didn't work. Okay. All right, so now let's look at how we find a solution when we're not given a graph. So sometimes you will be asked to solve. I'm gonna move these pictures. So sometimes you're going to be asked to solve and you're given 2 equations. So how to solve a system of 2 linear equations by graphing. So step 1, we want to make a graph of each equation. And you want to graph them on the same graph. And then step 2, find the point where the 2 lines intersect. Good. Okay, so this is where Unit 4 really comes into play. We have to put both of these lines or these equations in a graphable form. So we need to be able to graph. Remember our BFF form, y equals mx plus b? Slope-intercept form tells us a point on our line and tells us our slope. And if we know these 2 things, we're able to graph pretty easily. So B is our y-intercept. It's our point on our line. So if we can get our equations in slope-intercept form, we are golden in terms of being able to graph. So when we are doing these, it is important to use different colors. So that top one, we're gonna graph it in pink on this left coordinate grid. And the bottom, let's do this green color since Caden's not here. Okay, so before we graph, we have to get it in slope-intercept form first. Oh goodness, look it. Yay, this is already in slope-intercept form. Okay, so we know our y-intercept is -6. So we can put a point on our line right now at -6. And then we know our slope is -2. And remember, we want to write this as a fraction or decimal. Slope. Always write that as a fraction. So you see your rise and your run. Okay, so I'm going to change my cursor to pink here. Down at -6, 1, 2, 3, 4, 5, 6. Okay, there's my y-intercept, and then I'm going to go down 2 to the right 1, down 2 to the right 1 to find more coordinate pairs. Uh-oh, I ran out of room on that coordinate graph, so I'm just going to reverse my order. For my y-intercept, I'm going to go up 2 to the left 1, up 2 to the left 1, and because I had really good teachers, you guys, I'm able even to use, look at this straight line. Does that look like I'm going through them kind of?
Looks good.
Looks okay. All right, so let's see what happens here. So hopefully I've drawn my line long enough where it's going to intersect with the other line. Okay, so now I'm going to change back to red. Oh dear, look at this green equation. It is not in slope-intercept form. Wah, wah. So we need to put it in slope-intercept form. How are we going to get y by itself? I have this -4 to undo. Let's add 4, move it to the right side. And our equation is now y equals 1/2 x plus 4. Okay, now notice nowhere in the directions did it tell you that you had to do this. This is just something now that you're expected to know in order to graph a linear equation. It's best to put it in slope-intercept form. So this is where a lot of practice in Unit 4 is really going to come in handy. Okay, so now I'm going to do this in green. My y-intercept is +4. My slope, oh, it's already written as a fraction. How helpful. All right, so up at 4. 1, 2, 3, 4.
The two slopes of the equations are negative reciprocal, so it's going to be a perpendicular lines.
Oh my goodness, yes it is. I love how you noticed that. Negative reciprocals. So knowing that ahead of time is so helpful because when you graph it, that's a great check, right? You can be like, wait a minute, this was supposed to be reciprocals or negative reciprocals. They're supposed to meet at 90-degree angles. My lines don't. So that's a great self-check. And the more of those relationships you guys identify as you're practicing, the stronger math students you're going to be. Because math is all about connections and relationships. Oh, hot dog, they intersect right at a coordinate pair. I am so relieved. Oh boy, look at that. So the question, I'm not done yet. The question is find the solution. So what's my answer going to be? Where is the solution there? Where is the coordinate pair that they intersect?
I'm trying to write, but it's not really letting.
No, it might be because I'm hogging it?
I got it to work.
Oh, good. Good. All right. And so we need to write the solution as a coordinate pair. Yes. All right. So write your solution as a coordinate pair, your X value and your Y value. Oh goodness, there are even lines we can draw that have arrows on both sides. Woo. With annotate, I'm going to do that for the next line. Okay, so Malachi and Joseph, feel free to be asking questions of things that you see on here, just fill in holes, or if you want to clarify anything. All right, -4, 2, I agree, that's the solution. Okay, let's look over here on the right side. In order to graph these, we need them in slope-intercept form. Are either of these equations here in slope-intercept form?
Nope.
No. Notice the top one almost is. We have y by itself, but look at the right side. It needs to be simplified. I have a negative out in front. What in the heck am I going to do with that negative out in front?
You're going to multiply the things inside the parentheses by -1.
Good. Do you remember what that word is? It starts with a D.
Distribute.
Good. We're going to distribute that -1 through, and that is going to leave us in a beautiful, glorious slope-intercept form. Our y-intercept is right here. And our slope is -3. All right, what color should we graph that first one in? We haven't used orange yet. Let's use orange. Okay, Katie is going ahead, and can you tell us what you're doing there, Katie, on that second equation?
Since it's multiplication, the inverse operation to that is division, so you have to multiply both sides by 2
Beautiful.
to get
Or,
y by itself.
good, or divide both sides by 2 in this case. Great math language. Multiplication and division are inverse operations. They undo each other. Now, when we divide by 2, we can write it like you did like that, or we can divide each of those 2 terms by 2, which you're going to have to do eventually anyways. So good, that's a great first way to write it. And then your next step can be 6x divided by 2 and then -2 divided by 2, because we want to make sure that we divide both of these by 2. All right, so go ahead and write, Katie, what our slope-intercept form is going to be. All right, and I pulled these straight off of your 5.1.2 checkup worksheets. Beautiful. Y equals 3x minus 1. Okay, and Katie, in your honor, we will graph. Oh, ooh, I like it. Okay, we'll do that maroon red. Okay, Katie, which one do you want to graph? Orange or maroon red?
I'll do the maroon one.
Beautiful. Okay. So y-intercept. Okay, and I'll do orange unless Joseph or Malachi, either of you guys want to graph the orange line. Okay, so y-intercept is -4. 1, 2, 3, 4. Slope is -3/1. So I'm going to go down 1 to the right, or down 3 to the right 1. 1, 2, 3/1. 1, 2, 3/1. 1, 2, 3/1. Look at you with your lines there. Okay, so look at this one. Should go there and then it should go there. Okay. Notice our intersection is not right on the coordinate grid, is it? It's not, excuse me, right at whole numbers. So let's estimate it. 3/1, yeah, that looks good. Okay, let's estimate in this case where our solution is. So let's see, our x coordinate, it looks like that x coordinate is halfway in between. Yep, 1 and 2, I agree. That looks like it is at -1/2. Where's my? Okay, and then, oh, I like how you drew that in. And then the y, it looks like it's down at, does that look like 2.5 to you?
Yeah.
All right. Okay, so we are finding one of the challenges of using the graphing method is sometimes if the line doesn't pass through exactly a coordinate pair, you can't really be certain that you have the exact solution. So that's why algebra was invented. No, not why it was invented, but a great use of algebra. So we are now going to figure out how to do this with algebra so we don't have a situation where we have to estimate what the solution is. Okay, we're going to figure it out exactly. All right, questions on this one, 5-1. So graphically, where the lines intersect, the secret sauce for this is make sure your equations are in slope-intercept form so you can graph. All right. Need to move our faces again. I'm actually going to okay. Okay, so now we're going to look at an algebraic way to solve these called substitution. And in this lesson, or in this unit, you are going to learn 2 different algebraic ways to solve, to find solutions. So this is the first one. And then next week on Tuesday, we'll talk about the other form. It's called elimination. Okay, so we are going to now do this process algebraically using substitution. So in algebra, if 2 amounts are blank, you can substitute one for the other. So in algebra, if 2 amounts are equal, you can substitute one for the other. Okay, that's the secret to this. Okay. All right, Katie, I'm going to erase your writing just on this one, okay? Because we're actually, there's a easier way to do this one with substitution. Okay. Let's see here. Okay, so when we are doing substitution, the secret is, can you solve one of your equations for one variable? Is there an equation that is solved for a variable already? Or is it really easy for us to find one? And Katie, you were circling in on the x's, which I agree because that x is almost alone, right? But look at your y's. What do you notice about your y's here? They are alone.
So that means they're in slope-intercept form.
Yep. Okay. So your first step for substitution is to solve for a variable in one equation. It doesn't matter if you solve for x or if you solve for y. pick one. And you'll notice sometimes one of them might already be solved. So notice not only is this first equation solved for a variable, but we actually even have it here. Hot dog, we have two of them solved for a variable, meaning we've isolated a variable. Okay, so what this means is y is equal to x plus 6. This is also interesting because it says y is also equal to 2x plus 1. Huh, well, if y is equal to both of those things, can't we set those two things equal to each other? And so let's see how that works in substitution. I'm going to change my writing here. So since we have y is equal to x plus 6, what I'm going to do is I'm going to take x plus 6 and I'm going to substitute it in for y in my other equation. And here's what I now have. I have x plus 6 equals, and then just bring this down, 2x plus 1. X plus 6 equals 2x plus 1. Now, check in here. How many variables do we have in this equation? Do we have one variable or do we have two variables? We have an x.
Two variables, but they're the same.
It's the same variable. Notice we're down to one variable, which is what we wanted, because we can solve a stinking equation for one variable. All right, so let's put into words what we just did. So we can substitute value into the other equation. Okay, so I'm going to review here what we did. Up here in this first equation, I'm going to actually number these. So equation 1 and equation 2. Notice in equation 1, y is equal to x plus 6. So I took x plus 6 and I substituted it in for y in my second equation. And I rewrote what I have. X plus 6 equals 2x plus 1. All right, at this point, after you do the substitution, you're left with one variable. Okay, you have an equation with one variable. So you are able now to solve the equation for the variable that is left. Notice our y's disappeared. Oops, it's going to be very helpful. They just disappeared temporarily. Okay, so let's solve this equation for x. What do we want to do? Do we want to move the x terms to the left or the x terms to the right? There's no wrong answer.
To the right, because x is smaller than 2x.
Ooh, I like that. Hey, McLean. Sorry, my daughter has headphones on and is playing with the dog. Okay, good. I like how you determined that. So we're going to subtract x from both sides, and that's going to leave us with x equals x plus 1. Okay, last step, subtract 1 from both sides. All right, and did you get 5 there for x, Katie? X equals 5?
Yeah.
Good. Okay. So at this point, you've now solved a variable, x equals 5. Okay. I'm going to go back for a moment and look at some pictures. You guys remember these ones? Notice this coordinate pair is the same in both lines. So this one was 2, -4. So the x coordinate was 2 in both of them, and the y coordinate was -4 in both of them. So what this means is, if I would have substituted in 2 into either of these equations for x, what y value do you think I would get?
-4.
I would get -4. And would that happen in one of those equations or both of those equations?
Both of them.
It should happen in both of them. Okay, so this is where you get to choose what equation you want to work with. Which one looks the most friendly to find your other piece to your coordinate pair. So we know our solution is going to be 5 comma something. So how are we going to find our y value? Well, you pick the equation that looks the most friendly. So which one looks the most friendly, 1 or 2?
I think 1, because the x isn't multiplied by anything.
I agree. So we're going to use x plus 6, and we're going to substitute in 5 to find our y value. There you go. All right, so your solution to the system is 5 comma 11. Okay. Okay, so your last step here is to substitute value into either equation. To find the remaining variable. Oops. So question on this one. What if you were asked to verify algebraically that 511 is the solution to this system? How would you verify algebraically that 511 is the solution to the system?
You would substitute 5 in for x and 11 in for y in both equations.
And what are you looking for when you substitute them in?
Both sides of the equation to be equal.
Good. On both equations. Good. You want to show that this is a solution on each of those equations. Beautiful. Good. Okay, I think we just have one more slide. Here we go. So these ones will go a little bit faster because now we're working on our fluency. So this is why you have practice worksheets, is to increase your fluency. Okay, so we want to find the solution using substitution. Okay, so we want to try and think harder. What am I looking for? Think smarter, not harder here when we are doing these problems. So on this left one, is there an equation, 1 or 2, that almost has a variable alone, isolated?
No, because the x and the y are on one side.
Yep.
On both equations.
On both of them. What about equation 1 here? How many steps would we have to do to get y alone?
You would have to take away the x variable.
And how would we do that? We would add 5x to both sides?
Yes, because...
So at that point, we'd have y alone. So how many steps did that take us to get y alone?
1.
Okay. Let's look down at this one, the second one. How many steps to get y alone? How could we get y alone?
Also 1, because you would just have to add... Wait. I think, yeah.
We would add y to the other side. I agree with that.
I was confused for a second because of the y was taken away from 3x, but then I remembered.
Right, so we add y to the other side. What do we now have on the right side though? We have a y and a 9. So we would also have to subtract that y over to get y alone. So the second equation requires a little bit more work to get y alone. So I would encourage you guys not to use that second equation. It can be done, but I think for this problem, the smartest play is to solve for y in the first equation. because it only requires one step. Okay, so we're left with y equals 5x plus 7. Okay, and I like to circle things. Important parts, because then it helps me keep track of the information. And also as a teacher, I like it because then I'm able to help you identify where your boo-boos are if I can see your different steps. Okay, so I now have y solved by itself. We are going to substitute in y wherever we see a y in this second equation. So we're going to take this 5x plus 7 and we're going to substitute it in where we see y in that second equation. So let's write what we now have. We're going to leave the rest of the equation alone. So I have a 3x still. I have a minus. And I'm going to minus my y value. My y value is now 5x plus 7. What's the rest of our equation? We have equals 9. So at this step, we should have an equation with only one variable, only x's in this case. Is that the case? Are we left with only one variable?
Yes.
Good. So now we're going to solve the equation. Okay, before we combine like terms, I spy a negative touching that parentheses. What do we need to do?
You have to distribute the negative.
Beautiful. We have to distribute that negative or a -1 if you want to think of it that way. So I have a 3x minus 5x, -1 times 7 minus 7 equals 9. Now that I have all my parentheses gone, I am able to combine like terms. So -2x minus 7 equals 9. All right, don't lose track of your overall goal here. We're trying to get x by itself. So sometimes it's helpful to circle it or to highlight it to help you keep track of where it is in the problem. I'm going to add 7 to both sides. I have -2x equals 16. Divide both sides by -2. And I'm left with x equals -8. Woof, I'm done, right? Just move on, we're done. We've answered the question. Not yet, not yet. We're getting into big kid math, man. Okay, so we want the solution. Remember, your solution to the system needs to be written as a coordinate pair. At this point, you've only found half of that. Womp womp. We have found our x value. X is -8. So now we still need to find our y value. How are we going to do that? We're going to substitute -8 for x into one of our two equations. You get to pick which one looks the friendliest. 1 or 2. So Katie, do you have a preference which equation 1 or 2 you want to use to find y?
I don't know.
They're both kind of ugly.
Yeah.
Let's just jump in. Let's just use 1. Okay. And you will get the same answer regardless of which one you choose, as long as you've done your math right. Okay. Sometimes there's a benefit in choosing one because there's less steps. But nothing can make up for good old-fashioned hard work. So let's just get it over with. So I substituted in -8 for x. Okay, we're just going to take this bull by the horns. We plugged in -8 in for x. I'm going to simplify now. I have y -5 times -8 is positive 40. So I now have y plus 40 equals 7. I'm going to subtract 40 from both sides. And I get y equals -33. So our solution is -8, 33. Okay. So let's just look at this. This is a lot of work. So when you guys are submitting your summative assessments or even taking your quizzes in Apex in this lesson, notice there's a lot of work going into every single problem. So really important that you are practicing these really well before you take your quiz so you get feedback that your answers are right, okay? And that you're being reminded of what all your steps are. On your summative assessments, I'm expecting to see all of this work in your summative assessments, illustrating that you understand. Okay, any questions on that problem? That was a big one. So what we're looking for here as we continue to practice is that your fluency gets better, meaning your speed picks up a little bit, that you're not making arithmetic mistakes, and that you are identifying a little bit faster what the next step is going to be, because notice there's like 4 or 5 steps to solve these. All right, so let's do this one. This is also straight off of your checkup worksheet. And I think there's like 8 good problems on there for you to do to practice in Apex for this lesson. Okay, you ready? Last problem of the day. Last problem before Thanksgiving. Well, that we'll do together. Okay. Let's look at the second one. I'm going to change my color so it's not scary red all over the screen. I'm going to change to light green. Equation 1 or 2, which one would we like to work with here to get one variable alone?
The x is already alone on the second one.
It is almost alone. Notice it's not an
Except for
x,
the negative.
it's a negative. Good. So how can we quickly get rid of that negative mathematically? It is like we have an invisible, where's my cursor? Hello, cursor. There you are.
Don't you have to multiply it by -1?
Yeah, so it's like we already have a -1 in there. What undoes multiplying by -1?
Divide.
Good. So let's just quickly divide every single thing by -1. Good. Now rewrite what you have. X equals what?
-y plus 9.
Beautiful. Do you have one of your equations solved for one variable?
Yes.
Hot dog, you do. Okay, so we know x is equal to -9 plus y. So now is where we get to substitute. So to substitute, I'm going to take that value and I'm going to substitute it in for x where I see it in the other equation. And we're going to rewrite what we have here. So we have, now going to take equation 1. This is what we're working with. So we now have y minus 2 times the x value. Well, our x value is now negative y plus 9. Equals 3. And now notice, yay, hot dog, we only have y's left in our equation. That is great news. So now we're going to solve our equation for y. I noticed a -2 trapping in the items in this set of parentheses. So we need to distribute that through. And we're left with y. Oh, -2 times -y. It's a positive 2y. -2 times 9 is a -18. Okay. Katie, what are we going to do next to solve this equation for y?
Combine like terms.
Beautiful. So we have 3y minus 18 equals 3. All right. Add 18 to both sides. 3y equals 21. Divide both sides by 3. Y equals 7. Okay. Which equation would we like to plug 7 into to find our corresponding x coordinate? So now notice we know y equals 7. So we're looking for our x value. Which one do you want to do, Katie? A or 1 or 2?
I think 2.
Second one? Sounds good to me. Okay. Losing my cursor. Come here, cursor. There you are. All right. Okay, I'm going to change my color so you can see. Let me go to dark green. So now we're going to use that second equation to find our x coordinate. So negative x equals y minus 9. Negative x equals, we know our y value is 7. So 7 minus 9. Negative x equals negative 2. So if negative x equals negative 2, you can do it mentally and get x equals 2. You could also divide both sides by negative 1 to get x by itself. All right, and there's your solution to the system, 2, 7. Okay, so the great thing about this lesson is that when you're looking at your checkup worksheet, which is your practice bank of problems, it has all the steps and it even reminds you what the steps are. So it will say, now substitute for y or now substitute for x. So it does, the worksheet is really helpful, okay, to help you guys as you are practicing this lesson. Okay, so 5.2 is all about substitution. Next week, you want to be done with 5.1 and 5.2, so then you're ready to talk about 5.3, which is another way to solve the system algebraically, and then the rest of Unit 5 next week. Okay, are there any questions on 5.2 before we stop the recording here? Okay. Okay, so I am done with the lesson portion of today. I am happy to stay in here and talk to anybody who wants to talk about specific assignments that they've received feedback on. Joseph has a question. He wants me to go in and look at an assignment. You can work on your corrections, and I'm here to answer questions. Okay. If you don't want to stick around, I will see you guys next Tuesday, and enjoy your family this Thanksgiving and enjoy some downtime.
Thank you. Bye.
See you.
I'll see you next week.
See you.
I wanted to ask you, I want to see if you graded these assignments that I have. Did you grade? Okay, so you did not grade 5.21. So when you do grade 5.21, I want to ask you a favor. Can you grade attempt 2, because for attempt 1, for some reason, one of the photos that I inserted didn't go through when I was looking through it, and yeah.
Yeah, absolutely. Typically, yeah. So when I looked it over this morning, and you did great on it. I have not scored it yet, but it looks good. Like it looks like you're going to be full points on that assessment. Okay.
Okay.
Okay. So
thank you.
Yeah. So going through though, did you find feedback on some other summative assessments?
Yes.
Okay.
on others, but wait.
Are there any that you want to talk about?
No. You kind of already like answered some of my questions that I had today during the lesson.
Okay. Oh, good. Okay.
Because 5.1 it was like I understand, but like 5.2 I had like some questions and some ifs there, but yeah, you already answered it. Like
Good. Okay. Also, Joseph, the other thing I wanted to mention was we are meeting every Tuesday to go over a lesson. I would encourage you not to turn in summative assessments until after the Tuesday lesson, so you can make sure you get all your understanding filled in before you do your best work on the summative.
I usually do that. Just for this week, it was all my work done like on the first day.
Okay.
Because that's what I did with all my assignments. I did it all on Monday and Sunday.
Okay.
So I could just.
Okay. So that's something to keep in mind. Okay. Because a goal I have for you is that you want to only submit summative assessments one time. That means the first time you submit it, it's your best work. You know every single answer is correct because you've gone through and you've looked through the lesson again, or you've looked at your notes, or you've watched Zoom recordings and you know it's perfect. That's what I'm looking for, okay?
All right.
Okay. You still get full points if you get my feedback and resubmit. That's totally fine. But I think you can be doing a little bit better on your first attempts. Okay. So that's my challenge to you. Is that a deal?
Yes.
Okay. So best work. That's what when you see summative assessment, that's what I want you to think about is best work. Okay.
Okay.
And if it takes you a couple extra days to look up answers or to review, or even to send me questions and then I can help you, then that's okay.
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 Have a good Thanksgiving.
You too. You too. All right. Talk to you later.
Bye.
Bye. Hey, Malachi. Would you like to go over any questions, Malachi?
No. Once you, on the test, I looked over the answers you gave me, and I think I got it now.
Okay, good. Good. Yeah, I think you were just overthinking those ones because then you got the last two correct, which were kind of more challenging than the first three. So
Yeah. Happy Thanksgiving.
You too. Hey, also on those summative assessments, just like what I told Joseph, I want those summative assessments to be your best work. So don't submit them if you have questions.
Okay.
Okay, so get help from me first or go back and look in your notes before you submit. Okay?
Okay.
Okay, good. Have a great Thanksgiving.